November the 12th, 2014. The entire planet holds its breath as all eyes are on the Rosetta mission control room. It's the first ever landing on a comet, an unprecedented event coordinated by the European Space Agency.
How audacious! How exciting! How unbelievable!
Rosetta illustrates the extent and excellence of ESA's work. Technological know-how, scientific quest, cooperation in Europe and beyond, human adventure. A meeting between technology and dreams. ESA is the union of human efforts in space. It's the development of satellites and payloads in every area. Science, telecommunications, navigation, Earth observation, and human spaceflights. ESA is present across the whole portfolio of space activities, from the farthest to the nearest. So it can conceive things that nobody has done before. Land on a comet or on Saturn's largest moon. Map our galaxy with unprecedented accuracy. Obtain the most precise image of the first light of the universe. Better understand our planet and the causes and effects of climate change. Key to all these successes is independent access to space. Ariane has provided this for over 30 years, from Europe's spaceport in French Guiana. Today, the 6th generation of Ariane is being prepared. And with Vega and Soyuz at Kourou, Europe has complete autonomy and the capability to launch any satellite into any orbit. In Europe, an industry was created around these ambitions, resulting in wealth, discovery, innovation, and jobs. Most services we take for granted today rely on space. ESA has been central to European industry's development of systems and applications essential to the needs of our citizens. Without satellites, daily life would change. No entertainment or telecommunications, no navigation, no meteorology. Space is vital for our future, for our society, sometimes even for saving lives. And it's key for our economy, with important returns on investment. Space is also fundamental in inspiring society, especially our youth. Nowadays, thanks to ESA and its member states, the most advanced satellites and space infrastructures are developed in Europe. It's preparation for a new era, Space 4.0, to innovate, inform, inspire, and interact. ESA is taking the lead for a united space in Europe to face the challenges of the future.
ESA recently achieved a remarkable first. These images were transmitted from a satellite in low Earth orbit to a communication satellite in geostationary orbit using a laser. This European Data Relay System, EDRS, gives users on the ground much faster updates from satellites and has a wide range of applications, including improved maritime safety and emergency response. EDRS was developed as a public-private partnership between ESA and Airbus Defence and Space. It's part of the ARTES programme of advanced research in telecommunications systems. This ESA strategy is designed to stimulate competitiveness of European industry.
ARTES is all about innovation. ARTES pushes industry to innovate, to develop these competitive edges, to think about the very new solutions. They wouldn't do it on their own because since they are innovative, they are also very risky. And they need the public sector to really support them and mitigate the risks so that they will be able to develop the solutions and offer them to their customers.
Now that EDRS has been proven in space, ESA plans to develop GlobeNet, a high-speed data network in space using 3 geostationary satellites to provide global coverage. The Directorate also wants to support the development of mega constellations, large networks of mass-produced satellites operating in low Earth orbit, and invest in Pioneer, an initiative aimed at facilitating in-orbit test flights to develop innovative services, applications, systems and technologies.
It is very important that Member States remember that the telecom sector is indeed the main revenues earner of the space sector. Therefore, if the European industry would not remain as competitive as it is today, then this would have a strong impact on the rest of the sector.
Many of the technologies we rely on have come about thanks to government investment through ESA programmes, and there are wider economic benefits too.
If they invest €1 in ARTES, they will get a return that could be up to €21. This is not what ESA is just stating. This is the results that you can find in the London Economics study.
Evidence suggests that investments made now in ambitious new communications technologies will open up many new applications and commercial opportunities for space technology in the future.
The latest launch for Europe's new satellite navigation system, Galileo. With 18 satellites now in orbit, this highly accurate and civilian-controlled network is more than halfway to completion. Developed by ESA and now managed by the European Commission, the Galileo system will provide accurate positioning and timing around the globe and is fully compatible with GPS for the open service used by the majority of citizens.
As technology, it has fantastic potential. Everybody is using it either in their cars or in their smartphones or for professional applications, or the timing functions of the systems are used for financial transactions and all sorts of other things. So there are many applications in daily life.
With the first Galileo services soon available, ESA is now looking to the future of satellite navigation with potential new applications and innovations. At the ESA Ministerial Council meeting, the Navigation Directorate is putting forward its proposal for the Navigation, Innovation and Support Programme, or NAVISP.
With NAVISP, we're going to look at the integration of satellite navigation with terrestrial navigation, means with communications, and we're going to go well over the traditional boundaries of ESA in space and really look at how we can integrate space in the broader environment.
Satellite navigation technology like EGNOS, developed by ESA, is already accurate and reliable enough to be used by aircraft. NAVISP is aimed at investigating and increasing the range of services and benefits that could be provided by satellite navigation to European governments, businesses and citizens.
We're entering a new era with satellite navigation. It is relatively young. One can see a lot of people use it nowadays. So we are starting a whole new field of work where satellite navigation needs to be integrated with terrestrial technologies and means in order to move forward to the future, in particular, for example, for autonomous driving.
With Galileo, Europe now has a world-leading satellite navigation system. With programs such as NAVISP, ESA hopes to ensure that the full potential of the technology can be developed. Europe currently operates 3 launchers from its spaceport at Kourou in French Guiana. Ariane 5, one of the world's most reliable launch vehicles, capable of carrying up to 20 tons to orbit. Soyuz, a medium-class Russian launcher. And Vega, designed to launch the increasingly important class of smaller satellites. All these launchers provide Europe with independent access to space. At the last ESA Ministerial Council meeting in December 2014, ministers approved the development of next-generation launchers, Ariane 6 and Vega C.
we have major ongoing development programs with Ariane 6 and Vega C. This will allow Europe to enhance its strategic access to space, to enhance its position on the commercial market. The main objective is to lower costs and to be competitive on a worldwide level.
At this year's ESA Ministerial Council meeting, the Launcher Directorate will be asking for continued support for the launcher's exploitation and accompaniment programme, as well as launcher operations and future development strategy.
Short term is what we have in Lucerne is the support to exploitation, where we are working on the services from our launch base. We are also maintaining in operational capacity Ariane 5 and Vega. Then we have the midterms, which is still in full development with Ariane 6 and Vega C, and the longer term on which we have to prepare now Europe's strategic position for the future.
Maintaining this world-class capability in launch vehicles is considered vital for the future of Europe's growing space economy.
This is absolutely key to secure the independent access of space for Europe. There is a strategic dimension for Europe to have its own access, and there is a second point, which is the consolidation on the commercial market of our well-defined position.
Following the success of ESA's IXV re-entry vehicle, the Directorate will also be asking for support to develop a new reusable spacecraft known as Space Rider. Launched on a Vega C, this will be used to routinely access and return from low Earth orbit with a wide range of payloads and applications. Every mission starts and ends
This is the end of the Rosetta mission. Thank you and goodbye.
With mission operations. Over the past 50 years, the European Space Operations Centre, or ESOC, has overseen more than 100 missions, from planning flights to plotting orbits around the Earth and voyages to distant planets, asteroids and comets.
Our work begins way before launch of the mission. We determine the flight path, the orbit for Earth observation missions, for example, or the long way to a comet or to another planet. And we fly collision avoidance maneuvers if need be. So you only have control over a mission if you have the mission control room.
ESOC is at the heart of a network of ground stations around the world and centres of expertise across Europe.
I consider mission operations as basic for a space agency as launching a mission, for example, and therefore it's very important that our mission operations infrastructure gets adequately funded.
But space is a hazardous place. The Earth is surrounded by a cloud of debris from 60 years of human space activities, which could damage satellites. The Earth is also being bombarded by space weather, solar storms and charged particles ejected from the Sun. This could knock out satellites and even communication systems and power grids on the ground. Near-Earth objects also threaten the Earth and could potentially collide with our planet. All these threats are monitored under ESA's Space Situational Awareness Programme, which the Operations Directorate hopes to see continue to evolve.
We want to protect our assets in orbit and on Earth against impacts from space, may it be from space weather or risks from near-Earth objects. And we also want to protect our spacecraft in orbit from risk, for example, coming from space debris.
As well as providing core funding for mission operations, ministers will be asked to consider supporting space traffic management. This moves beyond monitoring space hazards such as debris and near-Earth objects to tackling them. Missions being proposed include AIM, an asteroid impact mission to test the technology for deflecting an asteroid, and a deorbit mission to actively remove space debris from orbit. Everything ESA does is based on developing new technology. Technology that enables a spacecraft to orbit a comet, investigate the atmosphere of Mars, return high-resolution pictures of Earth, or provide everyone on the planet with the world's most accurate satellite navigation system.
Technology is a little bit the hidden magic in the box, meaning people get to see the beauty of a mission. But if you land a probe on a comet 500 million kilometers away, that takes a lot of technology. And most of that is built by scratch for this mission. In order to be that good, you have to invest in research and development and test and trials a long time before.
In partnership with industry, ESA has a proud history of developing new space technology. Many innovative ideas, materials and technologies are first tested on low-cost missions, such as the ongoing Proba series of mini-satellites. Proba 2, for instance, recently captured this partial solar eclipse. The technology demonstration missions being put forward for funding at ESA's Ministerial Council meeting include AIM, the Asteroid Impact Mission. Launched in 2020, AIM is designed to help investigate how to protect the Earth against an asteroid strike. It will go into orbit around the Didymos binary asteroids at the same time that a NASA-built Hammer spacecraft will attempt to knock the asteroid off course. But it also has a much broader purpose.
We're looking at ways to radically reduce the cost and the schedule time of interplanetary missions. We, of course, introduced new ideas and new ways of doing things, but we don't take risks on hundreds and hundreds of millions of a new science mission. We do this on our technology missions in which we can accept much higher risk, and this is the case for AIM.
For ambitious missions like AIM to succeed and for ESA to continue to be a world leader in space technology, investments need to be made early. At the Ministerial Council meeting, ministers will be asked to support the General Support Technology Programme and Technology Research Programmes.
Technology goes through a whole development cycle, which we call the seamless chain of innovation. We start from the idea and we work along to develop it through our work in the labs, through the work of industry, and especially of small and medium industries, which are the vectors of innovation. But at the end, you need to prove that it works in the real place, space.
Technology development is the backbone of space activities, with benefits for European businesses, small and large, as well as the wider economy and society.
Earth observation is informing our society at a time when we face environmental challenges, be it changes in ice at the poles, atmospheric pollution, food security, or rising sea levels. ESA's Science and Research Earth Explorers missions study our evolving planet and deliver data to scientists around the world. The Kourou satellite, for instance, improved measurements of the Earth's gravity field, and CryoSat keeps delivering the first maps of changes in ice thickness at the North Pole or changes in sea level. A future mission called Biomass will examine the state of our forests and determine the amount of biomass and carbon stored there. A family of satellites known as the Sentinels is already monitoring our planet as part of the European Commission's Earth observation programme Copernicus. ESA will make sure that new satellites will continue to deliver what is needed to understand the future of Earth.
We are addressing a number of issues that relate to the development of new science, but also operational missions. For example, Earth Explorer missions, the scientific missions, but also we are preparing the next generation of Sentinel missions for Copernicus.
The science from ESA's missions is making an invaluable contribution to a planetary health check. This data is not only useful for scientists, it will also provide a future economic benefit through helping to develop business in Europe. But ESA's main objective is to take space technology to the next level, while making sure that data from its satellites is available for everyone.
The impact will be everywhere in society. For example, we have done a study recently where it was proven that €1 invested in Copernicus, in Earth observation, brings up to €10 back to the society. So really science is converted to business, and these business ideas are really good for job growth, for employment, for economic growth, which is absolutely required, and space is at the service of the people by supporting this.
The Directorate's proposals will cover everything from satellite development to providing long-term data on climate change. Data exploitation projects and public-private partnerships can also develop the commercial Earth observation sector.
In the next 5 to 10 years in Earth observation, we will face a number of challenges, some of them coming from outside. Big data, constellations, commercial companies entering our domain. And I think there we really have to see, as ESA, as European Space Agency, a public institution, how we can best react to these external challenges and position ourselves with our programs to really address these challenges from our perspective.
The challenges within Earth observation will be to deliver the new observation techniques required in the future in order to further improve Earth observation for the scientific, business and environmental needs of Europe and beyond. ESA and its member states will be taking important decisions on the future of space for Europe. In Lucerne, programmes in a number of areas will be put on the table for approval, ranging from ESA's science and technology, future plans for human spaceflight and robotics, to new launches, space safety and space traffic management.
The challenge is to find consensus between the member states about programs. It's a question of priorities, it's a question of money, it's a question of competition between countries as well, but in a framework of cooperation.
ESA recently celebrated 50 years in space. During that time, the Space Agency has sent European men and women to the International Space Station, furthered science and innovation, monitored our planet's health through Earth observation satellites, and fostered international partnerships. Access to space has also helped improve our everyday lives, be it by enabling prompt action for disaster relief or simply getting from one place to another. And space applications are becoming more and more important, from programmes in partnership with the European Union like Galileo, providing Europe with its own global navigation satellite system, to Copernicus, which offers extremely valuable data to improve the understanding of our planet and its environment. All this is possible thanks to European independent access to space. Ariane 5 has now broken the record of 75 consecutive successes for European launches. At the European spaceport in Kourou, French Guiana, Ariane, together with Soyuz and Vega, are securing their road to space with the capability to send any satellite on any orbit. The next step is to develop new launches, including small launches, attain lower costs and continue to be competitive on a worldwide level.
The most important success during the Swiss co-presidency of ESA that we reach an agreement about the free access to space and the independent access to space for Europe to be able to start a project for a new generation of launches.
The next generation of launches is needed to cope with the increasing expansion and diversity of space activities. ESA's robotic space science missions are transforming our understanding of the universe, be it by making unprecedented studies of a comet, mapping the stars in our galaxy, or testing the boundaries of new technologies. Continued funding will ensure future missions such as Cheops, which will search for planets outside our solar system. And they play a crucial role in Europe's growing space economy, which requires investments in new satellites and technologies like GlobeNet, a high-speed data network in space based on the European Data Relay System. In fact, many new ideas are on the table in all domains.
In general, about principles, it's easy to converge. When question of money and distribution of industrial return, then hard negotiations are sometimes necessary.
ESA's ministerial meeting will meet these negotiations head-on and will continue to fight for independent access to space to ensure a better future for Europe at a competitive price and with the best return for the economy of member states. ESA is ready to enter Space 4.0, promoting a united space in Europe for inspiration, interaction, innovation and information.